Next up is our dear friend Saturn. Saturn is 10 astronomical units from the Sun. Of course, everybody knows it is famous for its very, very obvious rings. It's quite large, about 10 times Earth's diameter, and that does not include the rings. It's very low density. This is a picture that you'll see all over the place, and I believe it's even in your textbook. And it's a picture of Saturn sitting in a bathtub. Okay, there is not a bathtub big enough to hold Saturn, but if you could put it in a bathtub, it would float, and that is because it has such a very low density. It's named for the god of time and the harvest, and Saturn. There is the Feast of Saturnalia, and the Feast of Saturnalia would occur in ancient peoples about the time of Christmas time. And one of the reasons why that was the winter solstice, and that winter solstice of around December 21st, that was the reason why Saturnalia, when daylight would start increasing, that's one of the reasons that that festival is at that time of year. Saturn's composition, mostly hydrogen, mostly helium. A lot of that hydrogen and helium got blown far out into the solar system by the early sun, with a core of heavier elements. So just like the last planet, if you landed on Saturn, it would be an atmosphere, then you'd have a lot of liquid hydrogen and helium. Eventually, way down here, it would get slushy, and you'd be thousands of miles into the planet before you actually started hitting anything solid. Jupiter orbits once on its axis every 10 hours. Saturn once every 9 hours. So these gas giants are rotating really crazy fast. That means that the winds on the surface are huge, over 1,000 miles per hour, and this bands on Saturn are very often large storm systems. There is a magnetic field around Saturn, about 2/3 the value of the Earth's magnetic field, that protects the gas, and it protects, again, many of the moons around Saturn. It also gives rise to auroras, so these are northern and southern auroras on Saturn, which I think is just cool, very cool. Let's talk rings. They were first observed by Galileo in the 1600s, and he saw an image, maybe not exactly this view, but something like it. And then a few years later, Galileo reported that the rings seemed to disappear, and he was questioning what could cause them to be there and then be gone. Well, if you look at this bottom picture, it is the same planet, but we are looking straight on at the rings. And if you look at them straight on, you can't see them. So you actually have to see them a little bit from above or below in order to actually see the rings. So what makes up the rings? They're broken apart bits of rock and debris. They come in different sizes. Some are as small as grains of dust. Many are about the size of a quarter. Most are about the size of your fist, and yet some of them can be as big as a house. So in movies sometimes they show probes or whatever going through Saturn's rings. You don't want to fly through that because it's a lot of stuff of different sizes that's going to pummel you. And so unfortunately, your dream of flying through Saturn's rings is not such a good idea. The rings of Saturn are within something which is called the Roche limit. Okay, it's not Roche, it's Roche. And of course it's named from a scientist who figured this out. All planets have a Roche limit. This is the distance from a star or a planet. Inside this distance, matter just won't hold together due to the gravitational and tidal forces of the planet. So here's what happens. If this is a little moon that has an orbit so it gets too close to a big planet like Saturn, here's what happens. As it gets closer, remember that gravity relates to distance. So the force of gravity on the front is going to be bigger than the force of gravity on the back of the same little planet. What that means is that it's going to cause that little planet or little moon to stretch. And the more it stretches, the force of gravity on the back is even bigger than the force of gravity on the front. Those two are not going to be the same. And what it does is it stretches this planet, and it stretches it so much that it starts to break it into pieces. Here are some snapshots from a computer simulation. And as this asteroid or little bit of debris gets past this Roche limit, it breaks into, it gets stretched apart, broken into pieces, and then the individual pieces then go into orbit around that planet or star. And that gives us the rings. And I will have you watch a little video on Saturn's rings later. Okay, so the rings are within the Roche limit, and all the moons of Saturn are outside this Roche limit. And the Roche limit is nothing but a mathematical point in space. Now, there are names to Saturn's rings. They were named in the order in which they were discovered, and they're not terribly creative names. They are named A, B, C, D, E, F, and the black spots are called divisions. So there's the Encke division, the Cassini division, and these are named very often for the astronomers who first found them. What keeps these rings in where they belong and what makes these dark areas, they're called shepherd moons. And shepherd moons, here's a really beautiful picture of a shepherd moon right here. That is a small little rock that has a orbit around Saturn, and the rings themselves are a lot of bits of dust, and this actually keeps the dust particles in line. So if they start getting out of line, the moon comes through, cleans them out, and pushes them back to either side. One of my favorite little things in the solar system is in the Encke division right here, there is this tiny little shepherd moon named Pan, and Pan was a musician in the ancient world. Another one of my all-time favorite pictures was from the Cassini probe. The Cassini probe flew past Saturn, and when it was out there, it turned around and it took a snapshot. And the snapshot it took was of Saturn, Saturn's rings, and way back out here, that's you, me, and everybody you have ever loved on that little planet right there. One of my all-time favorite pictures. Here's another one of my all-time favorite pictures, and this picture was actually taken by the Voyager 1 spacecraft that launched in 1977. Well, after it had been traveling for 33 years, they programmed it and said, stop, turn around, and take a picture. And this is the ultimate selfie, in my personal opinion, because this, looking back, has the entire solar system in it. Our sun, Jupiter, Uranus, Neptune, Pluto, Saturn, and somewhere so close to that sun that you can't actually, it's not even labeled, is us. There's you and me. Somewhere way back there, so tiny you can't even see it. Absolutely amazing. Now, Saturn has 62 moons, a few less than Jupiter, but these big guys, the moons are constantly changing. Now, the moons of Saturn are named for the Titans, who were the parents of Zeus, Neptune, Mars, and the other Greek gods. And there were a lot of them in the Titans, and so here are some of the bigger moons of Saturn. We're only going to spend time talking about Enceladus and Titan because they are the ones that are large and very interesting. So Titan is about 40% of the size of the Earth, so it's quite a big rock orbiting around Saturn. The thing that makes it absolutely interesting is that it has an atmosphere, and it's kind of smoggy. You can't see really well through it. This is aerial view of Huygens, which happens to be a probe, as it went through the Titan atmosphere. So it was very foggy, and then it started to come out, and actually you can see rocks and terrain below. It is the only other planet in the solar system that has liquid, solids and gases on the surface. Everything else is too hot, too cold to not have that. But the liquids, and there are liquid lakes on Titan, but the liquid lakes are not made of liquid water, they are made of liquid methane. And if you wonder what methane is, if you have a gas stove at home, you turn that gas stove on because you're going to cook a pot of potatoes, that gas that you're burning in your gas stove is methane. It's very, very cold, but it's fascinating, and there's a lot of continued research and continued probes going to Titan because where there is liquid, there's a possibility of ice. The other moon of Saturn that is very interesting is Enceladus. Enceladus, the Cassini probe that was around Saturn, took pictures like this one. This, of course, is an artist's rendering, but this and that are pictures from Enceladus, and it has a lot of geysers. So these geysers are not volcanoes. They are not spewing out magma. They are spewing out water. It is believed that Enceladus is so close to Saturn's rings that the tidal forces within it keep pushing and pulling on sweet little Enceladus that it keeps enough heat within it to produce a liquid, because you have to have heat in order to have liquid. And what's making that heat? Well, it's the internal friction from Saturn's gravity pulling on this poor little moon. And it actually orbits, Enceladus actually orbits within the E ring of Saturn. So it's close enough to have these liquid forces, but not so close that it's within the Roche limit. All right, that will conclude Saturn, and I have a little video on its rings I'll have you watch, and then we'll come back and we'll finish up with Uranus and Neptune.